is we're still going to do parametric equations, but our values for t are going to be angles. So if our values for t are going to be angles, then we're going to have cosine and sine back in the picture, because look, this is the unit circle. Our domain right here is the unit circle. All right, so we're going to plug in some values for t's for both x and y, and then we're going to plot the outputs for x and the outputs for y. If you notice, this is the beginning, the top, the left, the bottom, and the beginning of the unit circle. And that's purposefully because this is the only one, I might have to go take water, where we have whole numbers. Guys, will you write the whole numbers, the ordered pairs for the rest of those? There's zeros or ones. And we did that on purpose to make it easy. All right, so the right side of the unit circle is 1, 0. The top of the unit circle is 0, 1. The left side is -1, 0. The bottom is 0, -1. And then 2 pi takes us right back to the beginning at 1, 0. Okay, so what we're going to do is we're going to plug the first number in for cosine, the top equation. So that's going to be 5 times the value of 1, which is just 5. Now here's your sine. Your sine is 0, so 5 times 0, of course, is 0. And just do it on down this column here. For the next one, we know that cosine is 0 because we have 0 for the ordered pair. Your sine value is 1, so 1 times 5. Here we go with the left side of the unit circle. Look, this is -5, 0. The bottom of the unit circle, cosine is 0. 5 is a -1, so that's going to be a -5. And then right back to the beginning at 5, 0. All right, let's plot those on the graph, y'all. So if you notice, all of these units are 5 spaces away from the origin. So if you could please connect your circle. All right, so what type of curve is this? This is a circle. All right, so that was kind of a review. Here's what we're going to do. We're going to take the parametric equations, y'all, and I'm just rewriting this because I know that the top part is off my screen. What is a parametric equation set? It is a set of equations with more than 2 variables. And we have the letters x, the letter y, and the letter t. So what we have to do is we have to force this to only have 2 variables. So our best friends, the Pythagorean theorem identity, is over there on the top. That's not going away. So we're going to take cosine squared plus sine squared and set it equal to 1. So this value right here, this cosine needs to be isolated. So we need to move the 5. We need to divide both sides by 5. So x divided by 5 is cosine. How would we get sine value by itself? Divide both sides by 5. So this is the sine value. So if you notice, the letter t is nowhere, so we're progressing to do a rectangular equation. And we can do order of operations. We can square the top and we can square the bottom. But guys, remember, we knew this was a circle. And remember, circles don't have fractions. So what would we do to make this in the right form for a circle? Yeah. So when it comes to these conic sections, when it asks you to put it in rectangular form, y'all, that's standard form. You already know this. Every time you've been writing something in standard form, you've been writing these conic sections in rectangular form the whole time. So rectangular form and standard form are the exact same thing when it comes to angles in the domain of the unit circle. All right, let's look at this one. We're going to do the same thing all over again. We're going to plug in these ordered pairs. Notice that the t column is the same, but notice that the parametric equations have changed. So now we have 2 plus 3 cosine t, 2 plus 6 sine t. Let's go ahead and plug in these values. So cosine is a 1, so it's going to be 2 plus 3 times 1, which is just a 5. And then that is going to be 2 plus 0. For the top of the unit circle, that is going to be 2 and 8. For the left side, remember the cosine value is -1, so when you do your order of operations there. The bottom of the unit circle, and then back to the beginning again. All right, let's graph these. That is not a circle, but hopefully you guys see that this is a vertical ellipse. And you don't have to write the word vertical, but you can. I'm just writing the word ellipse. Now look, what is the center of this ellipse? That's right. Very good. Where else on here are some 2's? I know where some 2's are. They're right here. HK is hiding in these parametric equations. Look, notice how you didn't have anything added or subtracted over here on 1. Notice how it started at the origin? That's your H and that's your K right there. All right. So we are going to go ahead and write this in rectangular form, just standard form, y'all. You do not have to do this method because you should have standard form memorized. Remember, it's an ellipse. We know it's going to equal 1. The reason why it equals 1 is because of that identity. So it is going to be x minus 2, y minus 2, and then we're going to have a 36 here and a 9 there. And I did not count the squares. Let me show you where I got those numbers. Look, right there. That's your A and your B value. It's hiding in parametric equations this whole time. All right, so let's turn the page and kind of write down some rules that's not going to be given to you on your test. Look, I even drew a box to make sure that you did not lose where to memorize this. All right, so parametric equations for just circles and ellipses. You do not have to worry about hyperbolas, and the other one we'll talk about in a moment. X and Y equal. It is going to be H plus blank cosine T. I'm leaving a blank there on purpose. K plus a blank sine T. Now, the reason why I'm leaving them blank, because, guys, sometimes they change. We're going to do it based on this picture. So if you notice, that little graphic is a vertical ellipse. This is the A value. It is A places away from the center to a major endpoint. So the longer value on a vertical ellipse gets grouped with your y equals equation. If it's sideways like it is down here, then the A value's with H, but we'll talk about that later. So the B value's here. The center is what you always know, HK. So yes, this stuff works for a circle also. You know that it will be a circle if A equals B, like it did on problem 1. All right, let me show you what I'm talking about on this. We are going to do 3 in a moment, and then we're going to do 4 right now. So we're doing the opposite. We are actually writing parametric equations for the following. So on number 4, guys, let's find HK. Everything starts with HK. So I'm counting all the way across. I know the major axis is 12, so I went back 6 places and found the center. So HK is going to be 4, oh, no, negative 4, 5. Okay, so I'm going to write x equals, and I'm going to write y equals. Then I'm going to put my h and k in the little template, draw a plus sign. Now remember, this is horizontal, so the a value is going to go on the x equation, and the a value is 6 because the major axis is 12. Guys, look at the center. How far away is the center from the top? Yep. That's it. All right, let's now go to page 47. So page 47 is your homework, but I do want to do problems 2 and 3. I just want to do a couple more. I don't mind doing some of your homework with you. Let's look at problem number 2. Problem number 2 is a circle. We're going to write the parametric equation and we're going to graph it. All right, let me go ahead and do my little setup here for the parametric equation. HK is negative 3, positive 4. I'm going to draw a plus sign. And then remember, it's a circle, so the A value of 4 is the same thing as the B value of 4. And then you just put sine and cosine next to it with the letter T. So guys, you're not solving an equation, you are just plugging it into the template. That's all you're doing. All right, let's go ahead and graph the circle at negative 3, positive 4. Remember, it has a radius of 4. Any questions on how to do a circle? Any questions on how to do a circle? All right, let's knock out this ellipse. Let's do number 3. So, guys, where it says radius, that's kind of a misnomer. The larger value is always A. The smaller value is always B. So if the larger value is an x radius, we know this is a horizontal ellipse. Let's go ahead and get my little equation set up here. X equals y equals. I don't really like to write 0 plus, but I'll go ahead and write it for the demonstration of the example. Here's my k value, always a plus next. And then guys, look at my x equals. Does anyone want to take a shot and look at right here? A 7? Yes, great job. So this is going to be 2 sine t. Very good. Okay, so remember how we skipped problem 3? Let's go back to problem 3. Flip it back. Problem 3 is not an ellipse and it's not a circle. What is it? A parabola. What does parabola sound like? Parametric. So if I ask you to write a parabola in parametric form, don't overthink it. It is this simple. You just replace the letter X with the letter T. Now remember, parametrics have more than two variables. I have two variables, but what did I just tell you? You replace x with the letter t. Boom! More than two variables. So this is your set of parametric equations. So when it's a parabola, you literally just do that. That's it.